There's my first boo-boo. I shouldn't have paused the recording earlier. Oh well, I'll get another chance to do it again tomorrow for that part. All right, so we're back on track. So this is where we are coming up, heading into a holiday. And let's see, speaking of that, now everything I've got listed in course outline, I mean, I'm going to have to back off on some of that stuff because we don't want to overload you just because we're taking it slow trying to prepare for COVID. But if we go to week 3, it looks like a lot of things to get done. I got all these in, and I've even, hidden some of them because, but did you guys not, it was open. Oh, right. That's the reminder. Here we go. Let's pull that up. There we go. All right. Okay, so look, we come back and Monday's a holiday, so you folks won't be here, right? So I'm going to leave the due dates Sunday at midnight. And I know that, you'll be, it's holiday, right? Now, I'm going to be forgiving until Monday night, right? But the reason I'm leaving it Sunday in there in Blackboard is because over the years I've learned that people don't like it when that changes. And so unless it's different for a short one like we're going to talk about today, I'm going to leave it at that and then give you a break on it, and I'll put that in there. Plus, look, get them done before you go home be the right thing to do. And again, in 2 days, we're going to spend more time kind of going all through those things, right? Makes it a little tough on me because you'll have like 5 different things up, but we're going to get you through them. Master format one? Yeah. Well, that one we're going to do in class in 2 days. And I think I've got that one due at the end of that day. Now, the reason for that one, is that why you're asking? Because it looks like it's due right away? Because we're going to get it done in class. And there's a lot of good news around that assignment. I'm not big on, Professor Joswick wants you to memorize all the specifications. No, I'm just kidding.
I already know this.
He knows them, I don't.
Camera view, show me how to do that?
Yes, sir. If you guys would peruse through there with any other questions, and I'll be right back. Yes, sir.
So my camera, I want to write on the board.
Yeah, and if it's set right.
Right now, it's set for way over here.
Oh, okay. So I set a preset, me and the IT guy, and if you hit number 2, it should go to the board. But you do have to walk close. Right here, it doesn't work, which stinks. And if you see the light blink, you know it worked, but it's not going there. The 2 doesn't cut it. Try number, boy, somebody's reset it.
4
what?
Is over here.
Where's number 1 go? Okay, man, 2 was set. Me and this fella in the in the room over there. But if you want to, you can pan over.
It's doing any output at all.
Is it not blinking?
Well, the power line goes on and off. I can't tell.
He showed me that if that light up there blinks, it got the command.
Okay. So I'm going to use these camera selects.
Oh.
Or these.
Preset 2.
Preset.
No, don't hit preset. Oops, sorry. Yeah, 2.
1.
Oh, wow.
Nothing's
happening. That thing may be, is that light coming on?
This one is a little bit.
Oh, let's see. Camera select 1. Try hitting that. And then, it may have changed the cameras, but then go to try number 2 again.
Presets.
Nothing. Oh, there it goes. There it goes. All right, so it's that camera, and then the presets will work.
Okay, thank you.
You believe I took care of that?
I did.
Oh, no, that's all right. We're cruising. Okay, so anyway, on the master spec thing, again, I don't have them memorized. I don't expect you to memorize them. If you live and breathe them every day, you'll memorize them. So that assignment you're talking about, we're going to make a spreadsheet. We're going to take all these crazy amount of specifications. We're going to turn it into one little sheet that we also provide to you on the exam. And when I ask you a question about some spec number, what is metals in, there's no way you can miss it because it's provided, you know, and I had you go through the exercise. But again, I'll bet you, only 80% get one with it given. I don't know, you kind of freeze up on tests. I get it, you know. Okay, let's see. Can't decide if I want to jump into specs or scaling first. I think we should get the most important thing out of the way. Yep, let's just do that. Yep, okay. So, you know, you're going to want to bring these every time to class. And if you don't have it today, that's fine. What you're going to do is probably write down, if you're going to want to get a little piece of paper out, I'm not going to make you turn this one in. And if you don't have this to measure the 3 inches, you know, then just sort of guess at your 3 inches, which is another reason why I like for you to have the engineering paper, because guess what those are? If you don't even have a ruler, it doesn't matter, because those are 5 by 5 squares that are 1 inch square. So you'd only have to go across 3 of those to make a 3 inch line. I'm going to start with the engineer's one first. And remember, this is, the engineer's one is, we don't deal in inches. It's tenths of a foot, or at least it's scaled by base 10. So if I said that 1 inch equals 10 feet, I'm talking about on this side, and I'm using this paper and model terminology because if you've done CAD, they say paper space and model space. And I've already gotten outside of my camera limit. Let's see, slide that over maybe. You guys think about that for a second, okay? On the paper, if you measure 1 inch, it equals 10 feet. Ooh, that's, oh, it's mirrored, that's good, okay. Got 2 fans. Nope. Come on. That's getting close, huh? Yikes. Guess I'm going to have to slide all that over. Oh, I'll tell you what. Yeah, I got to do that too. So, all right. Please try to not overthink this. And forgive me if this seems crazy simple to you, but to some it's not. If we said that 1 inch on the paper is 10 feet in the real world or on a set of plans, and we went 1 inch on the paper, how many feet does that represent? 10. And then 20 feet, 30 feet. Now, when we're looking at that on the triangle, I don't even think that one's labeled. Anybody got their engineer scale with them? I brought my difficult one. Just hold it up, please. There you go. Oh, it does. Some of them, I was going to say, when you're dealing with the 1 inch equals 10, that's kind of the baseline. So on your little triangle, that's your measuring device. It's going to say 10 up there. And that's what that means, 1 inch equals 10. There's going to be other ones that say 20, 30, 40, and most of them go to maybe 50. Feel like, does anybody have the last one 60? Is there 60 on that one? Look at the top left or top right. 60, yep, and there was 50 there. Flip another one. 40, 20, 60 right there. Yep. There's 3 legs to this triangle, so there's always going to be 6 scales here. So this is as easy as it gets. If the drawing says 1 inch equals any of those numbers, you can lay that on there and measure it. So if you're able to lay out your line that's 3 inches, take let's do a little harder, a 1 inch equals 30. So you would lay your one that says 30 up on the side, top side, and put 0 on it. And whatever at the end of that 3 is how many feet that it is. So in this case, the first one went 30, 60, 90. Now that's physically, graphically, spatially. I've had many people that just sort of get the ratio right away because that's all it is, right? 1 inch to 30 feet is the same as a 3 inch line we measured to question mark. So here's cross multiplication, right? Cross multiply to solve for that. We got question mark. 1 inch equals 3 inches times 30. So that's equal to 90 divided by 1 is 90. So 2 ways to do it, or one way to, you can use the other one to check yourself. I know somebody's got a question. Because if you don't, it's the first time I've ever done an awesome job. I don't feel like that was awesome. Might be okay. It's all right. We're gonna do you'll have the homework where we're laying out a box. I'll bring it up here in a minute. Let's see. Yep, that works. Now, the architect scale, actually for me, is a bit of a struggle because I never use it. Twice a year. Which is why I definitely bring my architect scale. And I will probably boo-boo it the first time. No, that's all right. That won't happen. But I'm going to pick an easy one because, like, let's see. Well, we'll just, I'm going to use an 1/8 of an inch scale. Now, here's one reason architect scale kind of wears me out. Let's see, I probably can do, you guys care if I try to experiment with the document cam? Let's see what happens. Side document camera. Maybe. Probably got to turn it on or something. Yeah. It probably doesn't work. Can't complain though. The school does take pretty good care of things. So if it doesn't, it's probably unplugged. Oh man, I was going to try to be cute. Dang it. Oh, it might be picking it up. Nope. Not coming on. All right. I thought that would be cute. It's not. But rather than draw it terribly, perfect. That one will do. All right. Okay, so that's the architect scale, and that says 1/8 of an inch, or 1/8. Now, for those of you that have it, you'll look on the other side, and it's going to have 1/4 inch, because every one of these works 2 directions, which isn't all that fun. Because one, you got to read left to right, and one, you got to read right to left. And I know that's kind of extra cute, but the architect scale wants to cover more than just 6. So it tries to cover 12 of these. It only does 11 because the 16th doesn't go to 30 seconds. As a matter of fact, they got a weird one, 3 30 seconds. That's weird. Who uses that? And you'll also notice, and maybe your engineer scales has it, but definitely the architect's one does. Why do we have, that's 0, right? Because that's the first thing going to throw you off. Why are there marks less than 0? Because there's something else missing up there? There's no reason to put all the little marks in between those because it just makes the thing too dense, kind of like drawings. You don't put things on there that aren't necessary. Kind of typical. So that might be considered typical. And then you'll notice, let's see, I always have to zoom in here. Let's just look up there on the 8th. 1, 2, 3, 4, 5, 6. Now, we're back to dealing with, on the architect's one, we're dealing with inches, right? So the big numbers mean feet, and those little dashes in there between on the left of 0 are inches. But why do I have only 6? Well, again, they didn't double it because there's 12 inches in one, right? So and then if you're lucky, yep, that's what they do on that one. And then on the 4th, on the other end, you'll see 4. Yep, that's all they deal with. So what you have to do is you have to measure to the nearest foot, and then if it's beyond that, you slide it over. So let's see if I can do this. Really, Okay. Now, I'm making this line a little longer than 3 inches, right? I mean, if it was exactly 3, which is what you drew on your sheet, it's gonna end up from right there to right there. Now, if that line's a little bit longer, then you're gonna have to read these. This is still 1 foot represented in model space, right? Because we're looking at the one-eighth of an inch equals 1 foot. So that's why, again, why I hate those. 1, 2, 4. That's terrible. Somebody tell me that I've hopefully found a bad image. Because look on your 1/8 scale, and you tell me how many little lines you see there, little representations. I like those little ones, they're handy. Because that might be a boo-boo, because I'm actually trying to zoom in here, and I'm looking at... Nope, I'm seeing 3. You guys see 6 in there? 6. Yeah, it's terrible, but that's the way it is. Okay, now, I say it's terrible, but why is it 6? We have 12 inches in a foot, and they can't draw 12 of them in that tiny space. So each one of these represents 2 inches. That's ugly, isn't it? Some people just get this one and don't get the engineering, so I'm always interested to see which one sinks in. And so I want you to absorb this. Everything they showed with those little lines is supposed to represent 1 foot, which is 1/8 of an inch on the paper. And every one of these is 2 inches down here. You could have to guesstimate if it's between that to the 1. So if that line is really continues to right there, it's 3 inches, or there's 8/8 in an inch, right? So let's go get that first one. If we have 1/8 of an inch equals a foot, and we went a foot on paper, 1 inch on the paper, how many feet is it? So let me say it again because I boo-booed. You got 1/8 of an inch scale, so we go 1 inch on the paper. How many of those 1/8 are in there? 8. So that's 8 feet, right? 16 feet, 32 feet. Now, here's another thing that gets, another reason I'm not a fan of the architect scales. I just told you that 1 inch is 8. Why is there a 42 next to it? Because when you measure the other direction, it works for that scale. Whew. Nobody wants to laugh with me? Now, That's the straight 3-inch portion. And I said that it's going to go 2, 4, 6, 6 inches, or 0.5, but that totally would be to here. That was just to represent it. We got 32 feet, 6 inches, or you'll see later that's 32.5 feet. That's a dash between the feet, inches. So even though you read the feet to the right, you would have to slide this over to where the line starts to an even number, which is at 32. One, two. Oh, did you guys catch me on that one? Yeah? No one wants to tell me? I'm a doubler. I told you I'd get one part of it wrong. What's that supposed to be? Thank you. I've been doing logarithmic scales too long over the summer. All right, so that was a little choppy. So somebody asked me something about that. If we're going to use the quarter scale on that same one, that one has a 0 over here. And somebody tell me how many lines are on that, the other side. See, that's big enough, right? 2 times the size of that. Everybody got 12 little lines on that one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? Yep. 6, 7, 12, yep. Now, I've blown that up, so that's if we get to talk about, I'm doing pieces here that are not to scale, NTS. That one's a little easier to read. So let's just do a second one here with the 1/4 inch, right? Let's take a 1/4 inch equals a foot. Now really, from this direction, this reads 0, 1, nope, 0. I'm drawing the inches. And I don't want to draw the inches. Yep. I'm going to do that over again. There's 0 inches, 2 inches, 3 inches. Now, again, it's a little weird because you're measuring from the other direction. And if I've got 1/4 of an inch equals a foot, I have 4 in here. 1, 2, 2, 3, 4. So I will hit 4 feet, 8 feet, and 12 feet. Now, if it's a couple longer this way, right? I'm going to go to 1 shorter than the 6 inches, so 5 inches. So it's really going to be 12 feet and 5 inches. Can anybody tell me why they put the 1/4 inch and the 1/8 inch on the same scale? They're a factor of 2, so they fit. Same thing can be done mathematically in setting up proportions. This one is a little uglier. Again, we can do the cross multiplication. So we got question mark times 1/4 equals 2. And then if we divide by 1/4 over here, right? Divide by 1/4 over here, this equals 8. That's a proportion way. Again, I'm showing both ways because, again, some people like that. Some people visually graphic. Some are proportion people. That one's a little uglier because we had to divide a fraction by a fraction, right? Or at least a whole number by a fraction. So I know you'll want to go back and look at this piece of the lecture later. You guys are awful quiet, man. Somebody asked me something or point out something I've screwed up already. The whole gist of it is we take a paper space and a model space, even if the paper is digital PDF, it's still paper, virtually. So it's always that little ratio. And then again, the engineers is a base 10, and the architects actually, use 12 inches. Let's see that a little bit there. Get that in there just for the sake of it. I'm running out of space. All right. I'm just curious, who's used a scale before? Ooh, whoa. What class is that? Or just in high school? What is it? Yeah, architect scale. So my construction folks, seen a scale? High school, I mean, in the olden days. Speaking of that, today's my birthday. Yeah, man. So, I'm going to take a shot at me. My age range, just for fun here. Some say I have baby face, but these bifocals don't help out, do they? All right, am I in my 30s? No. Someone could raise their hand just for bonus points. No, I'm just kidding. Am I in my 40s? Raise your hand if it's 40. Am I in my 50s? Am I in my 60s? I'm 52. Born at 7-something in the morning. So I don't really believe in this stuff, but I'm a Virgo, which is why I like math and education, right? Anybody else a Virgo in here? Well, you hate it? Yeah. What? The stars weren't aligned right for you? No. Yeah, it's because it's malarkey. But it's funny to look at those things and, see the things in you. You might be one of the first Virgos in a while, though, that really I've found it's not totally into that. That's okay. Look, you can get through all this. It's going to start preaching it right now. I feel like the architect scale is one of the hardest things we do. And not in this class are we going to do trig. You take my surveying class, we're going to do a little trig. Otherwise, yes, you're going to have to calculate some volumes and surface area. So while I'm at it, I'm going to cover that. And again, forgive me if it's, but I had a student go the whole semester and never get the volume of a box right the whole time. And I'm not doing that to insult anybody who does that this semester. I just really don't want you to, if I can help you. It took, 65 times last time. I'll do 66 if it takes this time. Here's what I will plead with you. If you don't get this scaled, if you don't get this conversions we're going to do in a minute, and if you don't get surface area and volume, please, please, please do a session with me or watch some YouTube or both. I will help you. Ooh, who says teaching live is easy? I can't get everything lined up right. I may get crazy here. Let's just try that. We abbreviate surface area with the 2 letters in it most of the time. And if we got a little box, and that's not as square as I would like it, that's not bad. Okay, so surface area, we're just dealing with a little, we're looking at a plane view here, planar view, plan view, and we know that it's going to be length times width, right? It doesn't always really matter which one's which. I've had some people say, which one's length, which one's width? I don't know. Which way do you want to flip it? Now, in this case, it's a box. So it's just 3 times 3, 9, and that's square feet, right? Because units matter in this world. That's kind of a magic number. Actually, I picked 3 feet because what other distance is 3 feet long that you measure with, or your parents may have used? No, can't go there. They don't do that anymore. Anybody know what 3 feet equals in this world? Yeah? The yard, thank you. I've heard 2.7, 3.2, all kinds of crazy numbers. 3.2 is getting there because that's meters. All right, so that is also 1 yard. Now, we're not going to get into metric in this class, so we can avoid that. Now, I mean, if we took that same thing, and now it's not square, no big deal, right? I don't care which one is length times width, unless we're putting this in the ground on a set of plans, it's going to tell you which way is up. Matter of fact, when I draw this in 3D here in a minute, neither one of those is, well, I'll let you make your own conclusions here in a minute. So that's 12 square feet. All right. I'm sure, hopefully no questions there. Now let's try to go a little further. Let's deal with the volume, right? And let's see how good I am today on my 3D boxes. They get a little wonky. Not too bad. Forgive that that's not exactly proportional. That is a square box. So we want the volume of that. Now, if I was really good, nope, that's boo-booed, isn't it? That's not the right. Yeah, it's close. A little wacky. I better skip that. I'm not too good at that hidden line. I know that would be. I did have it right, didn't I? Yeah. I'm going to leave it though. You know, there's the back sides here, which is going to parallel that. Let's see. And then that's going to parallel that. Yeah, it's not bad. Those should be dashed through there. So that's behind there, right? And then this is always the trick there. Makes it a little complicated, but that's the back side of it. I'm going to erase that again because I really don't want you to have to think too much about that. Because we got 3 times 3 times 3, 9 times 3. What do we got? 27, thanks, man. Now, is that 27 feet? No. That's cubic feet. Now, why is that important? Because that is also how many is in a cubic yard. This is magic. You will need this. We convert cubic feet to cubic yards very often because really feet is kind of a small number when we're talking about construction. So if I told you that we had 50 cubic feet, I'm wanted that in yards, you would go 1 cubic yard is 27 cubic feet. So 50 divided by 27 is a little less than 2, or a little more than 2 something, right? What do we got? A little less. It should be 54. So 1 point what? I just made those numbers up. $50 divided by 27. You've got the calculator that you're supposed to bring. 1.85 sounds good. I was thinking close to 1.9. Because I found out that really one of the hard things is, you know, maybe you don't use your calculator all that often, and so it's good to be able to practice that with the calculator. So we're going to convert those things to cubic yards. And then it's the same deal, right? For something that's, say, 3 by 4, and let's just say it's, I don't know, 10 feet. You can call that the length. You can call that the width. We actually, you know, tend to call that the height. Now, I don't get too hung up on memorizing what that is, you know, because I just physically look at it, and if this is going in the ground, then I know that's going 3 feet down into the ground, right? And we'll get tricky later on where we kind of over dig to put a footing in or something, but this one's just going to be 3 times 4 times 10. So what do we got? 12 times 10, 120 cubic feet. Sound good? 12, yep. And then we'd do the same thing over here, 120 cubic feet. 1 cubic yard is 27 cubic feet. So we're definitely going to have 4 something, 4 point something. 4. Man, that's great. That's my favorite number. 44 anyway. Yeah, so, you know, we did scales, a little math, right? Kind of rough day. And don't sweat it too much. It doesn't get any worse than that. I mean, yes, we're going to calculate. Those of you out there in the virtual world, I'm going to point towards the floor here because we have these carpet tiles. And these carpet tiles look like they're 2 foot by 2 foot. So if you calculate the whole square footage of this room, how many tiles would you need if they're all 2 foot by 2 foot? So if we had a room 20 feet by 20 feet, we got 400 square feet, sound right? But I just told you that if we're looking at this room from a plan view, that's 20 feet by 20 feet. But one little tile is 2 feet by 2 feet. So one tile is 2 by 2 is 4 square feet. How many tiles do I need? 100? Because we took 400 divided by 4, right? And we got 100 tiles. Now, just to introduce you to something we're probably going to talk about more next week, but would you order exactly 100 tiles for this room? I mean, for one, you don't want to get shorted, which happens. But two, most rooms don't fit this nicely. Because I just made those up to fit nice. You're probably going to come up with something like, a lot of times, 100.8 tiles. Are you going to order 101? What if I told you if they come in packages of 100 minimum? You want to order 101 of them, but guess what? Unless you got a really good buddy at the tile store for commercial tile, you're buying 2 boxes of 100 each. So you hope they got another room, right? Which this is just one little room. They probably all get the same tile. But we will do a lab like this later. But this is the math. Nothing else. Because when I give you something like that tile's not 2 feet, but I say it's 18 inches. How many feet is 18 inches? 1.5, thank you. Awesome. All right, so 18 inches equals 1.5 feet. All right, so here's your first conversion of an easy one. Start out with 18 inches. We want this in feet. 1 foot, 12 inches. 18 divided by 12, 1.5. Now we got one last little unit conversion step. Let's go use that Now, I realize that you have calculators that let you plug in that. And I also realize, and again, by watching my daughter the other night, she knows how to do this by hand and struggled to do it with the calculator. Because if you don't put that right syntax in, right parentheses or whatever the heck it's asking for, and you hit equals, it's nonsense, right? And I'm not downplaying it, I'm just saying it's one of the skills that'll help you, as my first boss always said, you got to do the darn fool test, you know, and I love the 6-inch one because we can do a darn fool test really easy. I'm going to do this the long way, and then we're going to say, does that even look right? So what we got to do is, this is, feet and inches to what we call decimal feet. And then you're also going to see why engineer scales are awesome in a minute. All right. Now, this 32 feet, we're done with it, right? It doesn't change. We got 32 whole feet. But we have 6 inches. So we need to take that 6 inches, and we say that 1 foot has 12 inches, and that's that magical point 0.5, and that's feet. But it's 32.5, right? So we can't forget that. Let's just go over here. If you're just staring at that and you don't know a whole lot of measuring because we didn't take industrial arts in high school, it's okay because you know that 6 out of 12 is 0.5. If you come up with something different than that after you do the math, do the darn fool test and go, that's not right. So, you know, at least when we're dealing with inches, I mean, we know that, 2, 4, 6, 8, 10, 12, you know, 6 is half. Let's see, 6 is half. Oh, yeah, so really, you want to deal with these 3. Again, I love the surveyor's tapes. 0, 3, 6, 9, 12, 0.5, 0.25, 0.75, right? Again, I'm not asking you to memorize any of those, just pointing out that a lot of these things you can just kind of guess. You know, I'm letting you do the math on the calculators, but I'm still trying to keep my brain mushy and at least knowing whether I'm above or below some number. So these kind of help you keep in line. Now, you guys ready to get funky? And somebody don't smile once in a while. I am going to dance in here. Spread germs all over the place, so I won't do that. All right. There's a number I can't do in my head, but no big deal. 7, 1, 12. You'll see me write feet that way or that way. What's that one work out to be? What's 7 divided by 12? Anybody got it? What is it? 0.58. They probably got some other numbers after it, right? But that's good. 0.58, good. There are some numbers after it. That's feet. Now we've been past funky and now we're gonna get jiggy. So we got 32 feet, 7 and 5/8 of an inch. Here's where I start to lose people. And it's kind of a 3-step process, not bad, but we got 3 pieces to deal with. And if you're not very smart like me, as in I'm not smart, not that I'm smart, I got to eliminate the things that I don't need to sweat. And it, you know, again, sometimes it's just to get you going, right? It's silly. We know 32 doesn't change. But just kind of say in your head, okay, 32 is good. I had to do that 7, and we already did that, right? That's this 0.58 portion. But I got a 5/8 of an inch. So here's the one that gives people trouble. And I probably should know this one. What's 5 divided by 8? 0.6 something? Somebody else? 0.65? Now, I am not writing down units yet, because what units does belong to that number? All we did is take the parts of an inch, so it's still 0.625 inches. We had 7 inches, right? Now, there's a little trick you can do up here, but this would be we take these together, 7.625 inches. Everybody see that? That is not magic. It's not sleight of hand. What's 7.625 divided by 12? .635, sounds good. What's my units? Those canceled, I got feet. But don't forget about the 32. So really, that's a whole foot, 32 feet. So the full-blown answer is 32.635 feet. Some of you will realize that you can quickly kind of set up one fraction to do that. The ultimate goal is, after the first test, you get to use your calculator. As a matter of fact, I don't care if you're going to use it on the first one, but I'm going to make you show some steps so that I know you know how to do it before we move on, because then when you press it wrong in your calculator, it's no longer my fault. No, I want you to be able to make sure that you can do your calculator right by understanding those conversions. Let's see, we're done 11:40, 11:50, what have we done? What is it? 11:50. I'm going to show you the homework related to this that we'll also work on in class. We're going to take like a tiny break while you stare at this homework, and then I'm going to introduce specifications to you so I can get that lumped in here. Let's go ahead. Now, I'm calling this an in-class example exercise because you're going to give it a shot and turn it in before you come in next time. And then you're going to probably have questions, and we're going to look at it again because you'll notice that I'm showing it due after the next time. Let's go ahead and take a peek at this thing. So you guys stare at that for a second, and you can, was it open? Make sure it's open. Yep, so you can pull it up yourself, see what we got here. It's just doing the same things I just did up there, right? So take a peek at that. I'm gonna take a little break if you guys want to, and then somebody remember. All right, so I'm back to recording. Sometimes I know I better, ooh, that's good, okay. Should be still connected. Sometimes when I walk away, it wants to lose it. Okay, we're good. Okay, so what I've pulled up is chapter 2, what I'm calling point 1. So when I have a point 1 and a point 2, I've usually broken this up into a couple different types of lectures. Again, you'll notice we've got videos down here that exist already. So kind of doubling up on things. I'll put the sessions up that we're doing, and then you'll have Professor Nelson's to look at as well. So anyway, I brought up this one here. And let's go ahead and take a look. So this is obviously straight from the book. What I want to do, probably not. I'm not going to go into presentation mode so that I can keep the screen over here for the virtual world. Okay, so We got a lot of things that exist in the world of construction documents. We've mentioned that we got, you know, pre-bid, and then there's the bid and post-bid, and then all the addendums after that. But there's going to be, we've already looked at plans. Now we're going to start talking about specs. And remember, they kind of go in circles with each other, just like everything else involved in all these. And the format that we use, luckily, is somewhat standard for the most part. And we call that master format. There we go. Okay, so just in general, what we're going to head through here in the last couple minutes is that I'm going to basically describe the master format organization system, but then in class next time, it's kind of a twofold exercise. It's going to refresh your memory on how to use a spreadsheet, and then we're going to take this huge long list of specifications, and we're going to whittle it down into something that's more usable for memory. And then I'm not going to make you memorize it. But we're going to talk about some of the basic divisions here that you're going to live in this main construction world. And then we're headed to, throughout the book, these main divisions of concrete, masonry, metals, finish, site work, all that good stuff. Lots of objectives. I mean, look, here's all the areas and the divisions. We call them divisions. 14, we're still going. 28. Well, we're going to show you that there is 50 divisions, and then there's a whole bunch of numbers after that. And it sort of has some flexibility once you leave the first couple sub numbers. Now I'm going to blow this up. So I go over there, might as well. Yeah. Okay, so a little hard to see back there, but you can look at the PowerPoints later. We're looking at, I believe, 48. So we call this first one a level. So we're in division 48, which is level 1. And then level 2 is just another subheading underneath the big one. And then you can have 13.16, whatever, levels 3 and 4. Now that can go on and on if necessary, just like you're writing a real fancy technical paper. But those are the basic ones. When you look at that, you may say that on a drawing. Remember, we had some that had these specifications listed over as notes on the side that would tell you to go look at this division and potentially any one of these little pieces in here. For instance, 48, 14, 13.6, plate cell solar energy collection. So if you were the solar or electrical contractor, you're going to live in this one. I'm going to hit the high points today, not get down in the weeds. When we deal with site work, you're going to see there's a lot of specifications. Well, there's specifications hitting them all, but there are some pre-bid documents or other things in the specifications that wouldn't be called specs. We'll talk about soil information. So if you're in Division 4, you're doing masonry construction, all things masonry. That doesn't mean another little piece of it wouldn't reference another division. So not only are we setting in plans and specs, but you might go from one division to another division and maybe back again. I'm again not going to hit the, a little highlight here is if you're talking about concrete, you need to know about what kind of mix it is, what its compression strength is. That may be on the plans, and it may be in the specs, it may be in both. That's what this slide's showing you. Division 6, woodworking. 7 got its own thermal and moisture, so like waterproofing, curtain walls. Okay, so door schedule. Remember I mentioned door schedules as a drawing component? This is it in a specification, which is possibly a whole nother set of sheets, or this could be placed on a drawing, so they can show up anywhere. Yeah, so those of you involved in interior design and construction both are going to have to deal with finishes. And this is most likely going to show up in a specification because it could come through lots of other divisions. Okay, so a highlight here is that there may be codes out there that this has to comply with. So they may do what we would say is reference them. So the specs, and really the plans both, codes are either going to be totally included or just referenced. Most of the time, it's referenced unless it needs some clarification. Most of the highlights, but I want to show you what we're getting into. Yep, that's the one. Yeah, we'll show you that one. Okay. Boy, those are hard to see. Let's see if I can blow that up because that's not pretty. Yeah, that might work better. There you go. Okay. I'm going to point up here so that folks out there can see it. Remember I said there's kind of pre-bid, bid, post-bid documents? Well, any of that that needs to travel into the specifications is going to be in the front end. So that's procurement and contracting requirements. It's going to tell you all the things you need to know about. You probably know this already. You know, it's got your bonding capacities, all the kinds of requirements, tell you how you can get paid, all that good stuff. And that's division 00. So this is going to throw you for a loop a little, right? Because I said there's 50 divisions. What's the last number? 49. There's a 0. And you're going to get tripped up because obviously we put 49 and 50 as one of the questions. Big things to think about before next is that we really like to put these in group categories, and there's only 2 big groups: procurement and specification. But then there's subgroups, right? And then those are broken out by construction system. And then we have the divisions. So again, you'll have this to look at because we're going to make it, and then it'll be there for you, available during the test. Because I would say, in the end, we're going to ask you how many subgroups there are, how many divisions there are, how many groups or group categories. They all call them categories, but you got groups and subgroups, right? So I'm going to highlight that over here for our thinking into next week. All right, so and again, we got groups, subgroups, and divisions run throughout them, right? And again, 50 even though it says 49. So I don't want to pour any more water through the fire hose today because we did a lot of math, but I definitely wanted to introduce specifications to you. We're going to look at some examples next time, make these spreadsheets. I'm going to straighten up all the things that won't be due this week. I just put them out there so we could know they're coming. I'm going to kick some of those into next week. And then again, we'll have time in the next session where we work on any of the things that you're, having trouble with and help keep you up to date there. Try to get as much done for the holiday weekend, right? So we can enjoy it for the most part. Now, another reason why I put a lot of those things out there is it's a long weekend and maybe people are quarantined or not going anywhere. So you can get all these things done. Again, that's why I'll let those dates slide. But put them all out there so we can work on them. That's really all I got. But, come with your calculators, scales, because when we get back from holiday, we do that practicum, and this is where the rubber meets the road. Whether you chose to get the required materials or not, if you don't have the scales, you can't perform that. And the advisory board says that you will do that one. So anyway, get that stuff. If not, you can buy some used ones, cheap, no big deal. I highly don't recommend sharing anything right now because of COVID-19. Otherwise, share them's cool, fine. That's all I got. Have a good rest of my birthday. Yes, ma'am.
All of the assignments due Sunday, or is there one due Wednesday?
The one that's Wednesday is, good question. As a matter of fact, I'm gonna make sure this is still running because I want everybody to remember that. I have one due Wednesday because we're gonna make sure you can do
Is
it.
it Wednesday night?
Yes,
Okay.
because we're gonna go
I just
over
wanna
it
make sure
again.
if I try to do it tomorrow and I don't understand, it's not like due tomorrow night. I
No,
feel like
and that's the whole idea is I really should have made it due before that class and then come in and we fix it because if you try it, we get done fast. And I may just reiterate that to everybody. And you figure out what to come in and ask, right? Yeah. Yes, ma'am.
So I was just on the, materials assignment, I don't know, I just thought we had to bring it